we're going to chunk it down because that's a lot of stuff on there. So as I go through the lessons and stuff that you don't understand, I can show you how to do, okay? So that's going to be the plan today. So let me get these notes out, and we'll just chunk it. So here we go. So chapter 4, we're going to start with something simple, which is system of linear equations in two variables. Okay, this should have been on your pretest as well. You're going to decide for starters whether an ordered pair is a solution to the system. Second objective, solve the linear system by graphing. Solve the linear system by substitution. Solve the linear system by elimination. Solve special systems. And recognize how graphing calculator can be used to solve a linear system. So, I'm going to... I don't want to do the last one yet. So I'm not going to. I'm definitely going to do these 5. And then if I have time, I'm going to show you a fourth method to solving the system, 2 variables, 2 equations, that I really like. I did show it to you guys when you guys were freshmen. Actually, I show it every year, so you guys should be aware, which is using matrices. So if we have time after the elimination method, I'm going to show you how to do an elimination, with solving matrices, okay? So let's get started here. Say cheese, I don't know what that is. A set of equations called a system. So notice how you have 2 equations there, and they call it a system. Okay. Here's what I want you to know. Whenever we are solving a system of equations, we're just looking for one ordered pair, which is a solution to that system. And that solution is simply going to be where the 2 lines cross each other. That's our objective, people. So whenever they say solve the system, that's what you're looking for. That's it.
That's it?
That is it. There's nothing fancy about it. Okay? So to find where those 2 cross, notice how we can represent that as a coordinate, right? So that's what we're looking for. We're going to be after an x, comma, and a y. What's up, Callie? What? Who's going to beat you up? Alright, moving on. Down to this class. Alright, cool. Let's start with this one. This is really simple. Decide whether an ordered pair is a solution to the system.
Hey, which way is it? Is it variety is the spice of life, or spice is the variety of life?
I've never heard that.
It's variety.
It's variety is the spice of life, isn't it?
Yeah, that's what I told him.
Who's chewing your gum on?
You know, I could have been totally happy not ever having that discussion.
Whoa.
So I'm going to just move on. Okay, here I've got a system, and I need to check if the solution is an answer to that. And you need to know how to do this because when you solve systems, you're going to get a coordinate, and you want to make sure that that answer is correct. You don't want to be like, Mr. Munoz, did you check this? You should be able to check yourself and be like, good, hundreds, right? So, in order for a coordinate or a solution, or for an ordered pair to be a solution, the solution has to work for both of the equations. Okay? I've had where people have gone through the math and they only check one because it worked for one, they think it's good. But if it doesn't work for the other equation, then it's not good. It has to work for both. Remember, when they cross each other, that is the point where both of those equations are equal. They're the same, sorry. Both of those lines are the same point. So it's just a matter of substitution. 2, negative 4, plus 2 is supposed to equal negative 6. 2 times negative 4 is a negative 8. Plus 2 equals negative 6. Does negative 6 equal negative 6? So it works here. We're good. Then we check it with the other one. Negative 4 plus 3 times 2 is equal to 2. Negative 4 plus 6 is equal to 2. Does 2 equal 2? Good. So that means that is 100% correct. That is a solution to the system. Make sense? Easy, yeah? Questions? What's up?
Could there be more than one solution?
Well, let me ask you this question. When we're finding a solution, it's an ordered pair, right? And I said it's a solution to where the 2 lines cross each other. Will they ever cross each other more than once? Not if they're lines. So that's why I said that's a good question. Because sometimes it's not always going to be lines. Sometimes one of the equations will be a parabola and the other might be a line. Would you expect your solutions now? Yeah. Okay. Or if you have a parabola and a circle. Okay, you can have a circle and then a parabola kind of comes through it. Then I would expect how many solutions? You guys got the point? So, great question. Thank you for asking that. So, for this one, the green one is totally good. Let's check. Why don't you check the other point? Go and check it real quick. 3. 4. Oh, it works. Huh. So does the other one work?
Are you like surprised or are you being sarcastic? He's genuinely surprised.
I am genuinely surprised in a sarcastic manner. It worked for the top one, right? But for the bottom one, no? 3 plus 3 times negative 12. You can already see that that's going to be a massive negative number, right? So does it work? Does this have a solution? Or sorry, does this solve that? No. And we actually answered that question when Jacob asked his question. Will that system ever have more than one solution? No. You might get something that worked for one equation, but not the other. Okay? There's only one solution, which was A to begin with. So thanks for asking that, bud. All right, cool. Questions on how to check if something is a solution? Simple enough, yeah? Sweet. Pop. Same system? Oh, that's the other one. False. So moving on. Okay, solve a linear system by graphing. Let's try it, okay? Sometimes it's going to be easier to solve by graphing if they cross like nicely. You know what I mean? Like right at a coordinate. Otherwise, you're just guessing. Okay? And you could be wrong. Because like, let's say that point was crossing here. Okay? What x value would you give that? Negative 2.5? How is not negative 2.49? Exactly. So would it be a solution? No. So sometimes graphing is not the best method. That's why there's more than one, right? So let's try the graphing method here though. Let's see here. On the top one, let's see, I'm going to have y is a negative 5 when x is 0. So I've got a point here. And the other one would be when y is 0, x would be negative 2.5. That was a coincidence. Okay, so we connect those with a line. Let's see here. Up one, what is it? What's the slope there? Down 2 over 1. So it'd be here, down 2. No, that doesn't work. Why is it not working? Do it again. If x is 0, y is negative 5, which is there, yeah? And if x is 0, it is there. So what's our slope? It's negative 2 over 1, right? So down 2 over 1. Down 2. Oh, yeah, that's right. Because once it goes down there, it's going to hit that half point. So that means the next point will actually be down 2 and halfway point. So that means that we're hitting these little whole points there, okay? Make sense to everybody? I meant to do that. All right, next equation. When x is 0, what is y? 2. So it's going to be there. And if y is 0, x is negative 6, which is, whoa, out here. Okay, I'm going to have to draw more of these green points. But what's my slope here? 1/3. So I'm going to go up 1 over 3. Up 1 over 3. No. Thank you. Up 1, 1, 2, 3. There it is. Okay, cool. Now, you see that if I follow the green pattern, it's going to end up there, isn't it? As well. So that's going to be the solution to the system, which is negative 3, comma 1. Okay? It's not as easy doing it on the smartboard. If you have paper and straight edge, it'd be much easier that way. Okay? And graph paper. Graph paper will help. You just bought a bucket of it?
Bucket. Someone tried, like, my mom had a bunch.
Good.
Oh, I don't need it, so she gave it to my grandma.
Your grandma?
My grandma, like, I swear she's a hoarder.
Oh.
She's like a clean hoarder. I don't get it.
Well, then go ask grandma for some more. Like, grandma, can you give me some of that graph paper? All right, cool. So, yeah, you graph those two. Boom. Common point is right there. It's negative 3, comma 1. And then we're good to go. Everyone see that? Super simple? Okay, cool. Moving on. Systems can cross each other. There's actually four of them. No, okay. So you're going to get where they cross each other, you're only going to get one solution. Okay? The only special case of when they cross each other is what we call a perpendicular set, right? But other than that, then they're just going to cross each other one time. That's called a consistent system. Okay, that's just vocab. Make sure that you do know that. Notice these two are never going to cross each other, right? Because they're parallel. That means that they're always doing the same thing. So it's an inconsistent system, and we'll have 0 solutions. Now this one, you see how it's only one line? It's not really one line. It's one line on top of itself. Okay, that's called the coinciding system. But it's also consistent, and it has a number of infinite solutions. Because every single point on that you pick is a solution. Does that make sense? Questions on those 3 types?
So how many solutions is the everyone?
The infinite. Every point is a solution. Because the lines are right on top of each other. Which means all the points cross each other. So, 1, none, infinite. Okay? Can I move on? No, someone's sketch. How many people have got their hands on a graphing calculator already? Good, because at this point, you're going to want it. I'm going to tell you why in a minute.
And what's the name of the third one?
Coinciding. Those are called coinciding lines. These would just be intersecting, parallel, coinciding. And then there's another one where they're perpendicular. Guess what they're called? Perpendicular. Yeah, that's on my card. Baby, don't hurt me. No. I love that. Especially for Night at the Roxbury just blew it up too. Like it's made it 10 times better.
I saw it the other night.
Did you?
It's on Netflix now.
Is it?
Yeah.
I'll have to go watch it with the hairspray on the sideburns. That's ridiculous. Moving on. Okay, how to solve a system by substitution. Okay, I'm going to show you guys how to do all these things by hand. And then later on, I'll show you how to do it by hand some more.
What?
Okay, substitution method. Here we go. You guys ready? I don't want you there. Okay, I don't want you there. Take a look, examine the equations. Take a look at those. Look at the second equation. The second equation is telling you what x equals, doesn't it? What does x equal? What does x equal? 2 minus y. Isn't this an x? So what does that x equal? 2 minus y. So 5 times 2 minus y minus 3y is equal to negative 6. So now I've got an equation with how many variables in it? Technically it only has one variable, right? Now I can solve it. Something you need to know. An equation, if you get one equation, it has to have one variable to be solvable. One equation with two variables, you can't solve. If you have two equations, how many variables do you need? 2. If you have 3 equations, guess how many variables you need? 3. And that's kind of consistent throughout. So if you get a 3 by 3, you need to have at least 3 different variables and 3 different equations so that you can solve that bad boy. Okay? So that's just nice to know. 5 times 2, 10. 5 times y, negative y, sorry, is negative 5y. Minus 3 more y's is negative 6. I'm trying to insert a pause purposefully. 10 minus 8y is negative 6. If I move that 10 over, I'm just going to do this. Is that cool with you guys? Everyone understands that, right? That's what's going to happen anyway. I'm going to save myself some space there. So if this is negative 16, I'm going to divide by negative 8, which means y is equal to positive 2. Is it good there? I was trying to do the full house one. I just want to make it easy. So if y is 2, Medea, what is the value of x? What does x equal? Thanks for looking. Yeah, it does, huh? X equals 0 because if y is 2, that's a y. So 2 minus 2 means that x is equal to 0. So I would say my solution is 0, comma 2. Now, does that make it true? Not necessarily. This is a point where you check your work. If you don't check your work and it's wrong, then yeah, right. You're wrong. Okay? You fools, you just lost points. So here's how you do that. Same as we did the first one. 0 is equal to 2 minus 2. Does 0 equal 0?
Yeah.
So it works here. 5 times 0, that's 0. That's going to be a 2, which gives me negative 6. Does negative 6 equal negative 6? Hundreds. Sometimes. Not so much on rainy days. But yeah, that's it. Questions?
Maybe we should read.
Bell should ring. It should rain.
I just watched my
So did I.
movie time.
And it got
Well, you know what?
I hate when I do
I finally.
I hate when it rains because my car's dirty, but because it sits under the shade, the solar panels, enough water gets in there to just make it look nasty. You know what I mean? Like dirty looks like alright, it's dirty, but now it's all muddy and crappy, and
that. Myself.
you know what I
I
mean.
haven't watched my took in like.
All right, cool. Moving on.
Finally
So you're talking about like the parking lots here?
Yeah,
Yeah.
because you just get enough rain on there where it just turns the dust into like mud. Like, thanks, dude. Okay, so we did all that already. We're good to go. Wow, they made it look harder. Cool. Okay, now this one's not as easy as the other one was, is it? It's not set up for us for substitution. So you're going to want to take a look at those and see what how you can make it work for you. Now, looking at it, because I have experience, I can see that at the top equation, if I just move that 4x over, I would get a y equals, wouldn't I? So if I took this and made it a minus 4x, I get a y equals, don't I? So plug the y into this y, and then solve it again. So 2x minus 3 times y, which is 5 minus 4x, is equal to 13. Solve it, get x. What do you do with that x? Once you get the answer for x, once you get x equals something, plug into what? Yeah, that top equation. See how it says y equals? You made it already, so just plug that number in there. Anybody want me to just finish this? Yeah? Should have just done it. So 2x negative 15, positive 12x is 13. 14x minus 15 is 13. So I'm checking my work. Looks right. I'm going to add 15 to this side to make this go away. So 14x is equal to 28. And you guys can see that x is going to have a value of 2, correct? Okay. So what's y equal to? Kelly?
Zero.
Wait, you plug it
Well,
into
well,
the
here's
front?
y equals,
Oh, wait,
right?
no, master. Wait, that negative 2 or 2?
Here's y equals right up there. Negative 3?
Yeah.
Yeah, so if I plug my 2 in for x, that's going to give me 5 minus 8. So yeah, y is negative 3. Now, I used to do this when I was in high school, and I lost my points. You know the answers were right? And you will lose your points too. That's what I asked.
Wait, what?
That's what I asked too. Like I would do that. Like here's x, sir, and here's y, sir. Please refer to the boxes.
Please refer to the box.
But remember, what did we say the solution to a system is?
An ordered pair.
It's an ordered pair. So because I did not do this, I lost my points. And you will too, not just here, but if you take an ACT, if you take whatever other test you will take from now on, same thing. Because there's certain things that we do in math and their expectations. Okay, what the solution to a system is an ordered pair. And that's why we said it. So please don't be that guy. Don't be Munoz.
Refer to the box.
Don't be like refer to the boxes. Because that was appropriate, right? Like you always box in your answers. I thought I was cool like that. No.
Is the SAT multiple choice?
Or it's multiple guess if you don't know what you're doing.
What it is?
I believe so. I think there's a part that is I don't know. It's been too long for me. I don't remember. I'm not gonna try to.
Is it hard?
Is your short answer?
Like you solve it and like you have to like write it in and bubble the numbers. You
Cool.
don't get answers. And you then you have to solve it.
Awesome. See that?
Is it hard?
It's scary.
It's scary. It's not hard. It's scary. they got a bouncer standing over you the whole time. Does it feel that way?
It does. It's breathing down your neck. It's terrible.
I gotta take mine.
Okay, so there's that one's done. Okay. Ah! Why for you do this to me? Right? Fractions? Is that everybody's thought too? Drop out because fractions? Ooh, we just said the F word again. Remember the little trick I showed you? What's the common denominator there? 4. Multiply everything by 4. Watch what happens. 2 goes in there twice, so that becomes 2x. 4 goes in there once, so that stays as a y. Equals 2 goes in there twice, so it becomes that. Did everybody see what I did? No?
Yeah.
Okay, let me make it clearer then. I found that the denominator was a 4, the common denominator, so I multiplied the whole equation by 4. So everything got multiplied by 4. And that produced for me a new equation down here, which is 2x plus y is equal to 2. Much easier, yeah? This is actually a skill that you need once we get to elimination. Okay, what I did right here. You'll need to be able to do that for elimination. Okay, at this point you can see you can move the 2x over, plug in, go through the process. You guys want to do this on your own? That's a good idea. Do it. Do it. Do it. Do it. Okay, I had to check because last year during one of my classes, there was 2 chicks watching Netflix the whole time. Like I had to go back there. Like every time that would go away, Netflix was right back on.
It was
Like, are you serious? Huh? It was in stats time. I didn't want to put anybody on blast, but I know. Just say we don't have to worry about them anymore.
Big argument.
Yeah, sure.
Oh, yeah.
That's why I got my spy back there. I'm just kidding.
Munoz, what is your fourth hour supposed to be doing?
They're supposed to be programming. Well, except for that back row that you're looking at. I don't know what they're doing.
They're not doing that.
I'll tell you what they're doing. They're failing.
Ooh.
That's the truth.
What is that class?
It's AP Computer Science.
What do you do?
Program.
Yeah, they're learning how to code with, it's called block coding, called Snap, and it teaches you the basics so that once you jump into any language you want, you know how things are supposed to work.
So that's hard, huh?
It's yes, and it's fun.
I tried coding once.
The
Just because I
background
thought it was
is
a
like
game.
Coding? You tried coding?
Yeah.
That's why I had to change the rules on them.
Did it? Did it sound like I said?
Like
I tried coding.
they were struggling at first; it was really tough. So I said, you know what? When you get it done, you get it done. But that row back there is like 1 month behind.
Oh, Jesus.
So I had to say, you know what? You get 1 week and that's it. You heard me yesterday. Because you guys are not doing what you're supposed to be doing then. So they have a week. I want to see how they catch it. I try to be nice, but they're not. Let's see, Ruben. Who's not here? It's, okay, we're good here? Move on? Because I want to get to the elimination. Okay. Substitution used to be my favorite method because I understood it. But it turns out that sometimes it's easier to eliminate something. Okay? And I think I started talking about it yesterday. Okay, elimination. It really is that. You're trying to eliminate one of the two variables. You're trying to get rid of x, or you're trying to get rid of y completely. And the way that's done is through this thing called linear combinations. Sometimes you'll hear that referred to, instead of elimination, they're called linear combinations. But what you're doing is you're adding the two equations. But you're adding them in such a way where one of the variables adds up to be 0. Okay? So they kind of go away. They go away. So for example, they're going to give us an easy one first. They're going to toss us a little curveball there. What is it? Underhand toss? What do they call it? So take a look at this one. If I added these two
Don't
equations,
throw Josh a curveball.
if we added these two equations, can you see how the x's would become zeros? So it really is this simple. Negative 2x plus 2x is 0. That's gone. So I'm going to get 5y is equal to negative 5 if I add the two equations, don't I? Ever see that? So what does y equal? Y equals negative 1. Bam! I'm halfway there. Isn't that beautiful? I like it a lot. So what do I do with that y?
Plug it in.
To which one? It doesn't matter. It doesn't matter. Pick one. Because remember, the answers have to work for both, don't they? So I would pick the easier one. This one? Oh, you're telling me the answer already? Let's.
No, it's just no.
Okay, I'm going to use this one then. So 2x. I thought you were telling me the answer. I was like, what? Okay, that's going to be negative 3, so I'm going to add 3 to both sides. Right? Oh, that what are you talking about? What are you talking about, Willis? That's not right at all. 2x minus 2 is equal to 5. Plus 2 plus 2. Hey, why doesn't that look right? Is this wrong?
Yeah, why is it a negative?
Because negative 10 plus 5 is negative 5. It's going to be a fraction. It's going to be a fraction, guys. So this is going to give me 7, right? Divide both sides by 2. So x is equal to 7 halves. So there's x, there's y. What do I need to do? Check it. Obviously, I'm a little suspicious about it because I did get something weird. Well, it's not weird. It's just improper fraction. But I'm saying that that's my solution. I'm going to have to check it. So I'm going to start with the top one. And I'll do it in green so you can see me checking the top one first. So that's 2 times 7 over 2 plus 3 times negative 1. And that should equal a negative 10. Okay? So let's see. It might work. The 2's are going to make a 1, aren't they? So I've got negative 7. Oh, look at that. It does work. It does work for the top one. That's magic. I was iffy too. I'm not going to lie. Let's try with the second one. 2 times 7 over 2 plus 2 times negative 1 needs to give me a 5. So again, the 2's are going to make 1. So I've got 7. That's a negative 2. 7 minus 2 is 5. It works. So that is 100%. You can take that to the bank.
Okay. How do you know the difference between that one and then the one we just did before that?
What do you mean?
Like, how do you know if you're eliminating or if you're doing?
No, that's the thing. You don't have to decide which one to use. You pick one. I could have used substitution if I wanted to. But what I'm showing you are methods.
Okay.
There's one way to do it is graphing. I could use substitution, or I could use elimination. So it's just tools in the toolbox. It's all different ways. I could do this by substitution if you wanted me to. Would you like to see that?
It's all the way.
Okay, you believe me? Good. So, yeah, it's the same thing. I would probably move this over and then divide by 2, plug that into the other equation and do that. So, they're just methods, okay? Are we good? So, moving on. Of course, they're not always going to be that simple, are they? And this one was really that simple, but here's the elimination method. Is there anything that would easily cancel itself out here? No. So I'm going to have to make it work for me. Okay. You guys remember what I did with that one equation with the fractions? I multiplied the whole thing by 4, didn't I? So technically, I made the whole equation, Peyton, I made it 4 times bigger, didn't I? Okay. Here I'm going to have to pick something. What do you guys want to get rid of? Hudson, what do you want to get rid of, X's or Y's? Why? Because one's negative already and the other one's positive? That's a great reason. Did you need one? No. But that's a great reason. Okay? Now, here's the deal. If I'm gonna try to eliminate the y's, what's the like LCD thing between those two numbers? The 3 and the negative 7. What would be the smallest number that they both fit into? 21, right? So what I want to do is I want to make this become a positive 21y and the other one be a negative 21y. That would work, right? Wouldn't that work? If I combine them, they would make 0? Okay, so what do I need to do to this equation up here to make that happen? Multiply by 7, correct? So I'm going to do that. So 7 times 2 is a 14x, and that's going to equal a lot. Let's see here. What is that? 140 minus 9, so 131? 133? 133 minus 7. It's because I rounded it to 20, so that gives me 140. But then I added 7 1, so I take away 7 from 140. That was the whole rounding lesson in 2nd grade. No? Do you see everything coming back? No? Okay, never mind. What do I need to do to the bottom equation to make that a negative 21 happen? Multiply by 3, right? So I'm going to do that. 3 times 3 is a 9x. There's my negative 21. And that's going to give me a negative, what is it, 18? Yeah? Okay. So what I'm going to do is I'm going to eliminate from this system. It's equivalent as the top. It's the same thing. It's just one is 7 times bigger, the other is 3 times bigger. But they're equivalent. I just combine them now. Yay! What's this going to be? 23? 23x? And then the other one? Okay, I can round, but I can't subtract. Take 20 away, that's 113 plus the 2, 115. Divide by 23. X is 5. What? Oh, because I went 20 goes into 100 5 times, and then 5 times 3 is the 15. It's rounding. I'm good at rounding, okay? I'm sorry. Some things are good at, some things I'm bad at. Like my times tables, my multiplication. my times tables, I can't do like 6 through 9. Actually, 9's I got covered on my fingers now, so I can't do 6 through 8. Like if you go 7 times 8, I'm like, how much? I was gonna say 48. See, I'm not good at that. The problem is when we were doing that in elementary school, the method was it's kind of like this thing called the whole learning experience. Like you didn't have to know the right answers, but you knew what needed to happen. So if you told me what's 7 times 8, oh, it's 7 groups of 8, and I can add them all and get the number. So I understand what's supposed to happen, but my facts, I wasn't drilled on facts. So I'm drilling my kid. I'm gonna drill her all day long. She's gonna be saying it in her sleep. She's in kindergarten. I'm teaching her addition right now.
Are you really?
Yeah, she's good too. Like, yes, be better than me. Be better than me. All right, and then here's what you're gonna want to do to get y. Take the solution. Take the solution and plug it back into one of the original equations. I think someone said it earlier. You always want to go back to one of the original equations. So that means that 2 times. I'm gonna use the top one. So 10 plus 3y is equal to 19. 3y is equal to 9. So y is equal to 3. Guys see how that works? Sorry, did I do that too fast? Okay, sorry. So I'm plugging into this equation, my solution. So that's 2 times 5 plus 3y is 19. Right? Okay, I just did it. So 10 plus 3y is 19. Take 10 from both sides. 3y is 9. Divide both sides by 3. Y is 3. So Brittany, what's my solution?
5.
5 comma 3, good. Is it right? Yes, because you did it, Mr. Munoz. You checked it already? That's a nervous grin. Moving on. Okay, special systems. Oh, sorry. Was there any questions on this last one? Everyone was good? Everyone was good here? Huh?
He said movie time.
No.
You snitch.
There's no movies. You can snitch. It's all good. Before you just jump into doing the problem, do you remember how I made equations bigger on the last one? One was 3 times bigger, the other one was 7 times bigger. Take a look if you can make the equation smaller. Wouldn't you rather work with smaller numbers also? Okay, so someone said, oh, I can divide everything by 4. But even more, I can divide everything by a -4. So I can get rid of all the negatives too, can't I? So if I divide this whole equation, or I multiply by a -4, which is the same idea, that's going to give me 2x plus y is equal to 6. Oh, wait a minute. That's the same equation as that one. And if they're the same equation, how many solutions does it have? Infinite. And I'm done.
That's it.
That's it.
Hold on, I need to write.
Yes, we didn't even have announcements.
Good.
Yeah, we did.
Yeah, we did.
Yeah, we did.
No, we didn't.
No, we didn't.
We said the pledge. Wait, did we?
No, we
Yeah, we
didn't.
didn't even say the pledge.
You're just used to saying it, that you think you said it, but it didn't happen.
I swear we stood up.
What did you say, Kelly?
No, because I usually do the attendance during those announcements, well, right after the announcements, because they're talking. Sorry, after the pledge. And then,
You needed a chance to-
and my attendance is not done yet.
Oh.
Are we good?
I'm okay with this.
Oh, that's what we just did, huh?
Vanilla milk's on the
Okay.
phone.
Now, this one's optional. This is probably for, like, anybody that already has those or wants to see another method. Steve, I don't know if you've seen this. What, using matrices?
I hate matrices. Don't even talk to me.
How do you hate matrices? They're like the most beautiful thing.
You're the most beautiful thing.
Check it out. I'm gonna make I'll call it the main matrix, okay? And the main one's gonna just have the coefficients. So 2, -8, 1, and -4. So does everybody realize that these are the x's, these are the y's, right? Are you okay with that?
I got these all right on the paper.
Okay. So this is gonna be the I'm gonna call this one matrix D. Okay. Now, here's what I'm going to do. I'm going to do another one. And here's what I'm going to do. Ready? What is 2 times -4?
See, that's where it gets negative.
No, it's just an x. What's 2 times -4?
-8.
-8 minus, what is this product? -8. So that's going to give me, hold on, I did that wrong. Probably plus. So that's going to give me -16, okay? You're good with that? That was hard, huh?
Wait, I don't
Yeah.
get
See,
that.
it's like easy ones like this, but then when you start getting into like the bigger matrices,
Oh, well, yeah. You're talking about row swapping, and that's beautiful. That's fun math. That's geeky math. But I'm going to show you something cooler than that in a minute, okay? So we're good here. This is for everybody else that just wants another option, okay? You could do that, right? Now, the next one I'm going to do, I'm going to call this one the dx. Okay? Dx. And here's what I'm going to do. Because this is dx, I'm going to put the answers in the x column. Okay? So 6, -24. And then the y's, I'm going to leave it alone. So 1, -4. You cool with that? Everyone okay with that? Everyone see what I did? In the dx matrix, I'm putting the answers in for x. And I'm leaving the y alone. Not a big thing, is it? And do it again. So what's 6 times that? That's -24. And I'm going to add to that -24. Which gives me -48. Cool? One more time. Guess what this one's going to be called?
Oh my god.
Is it really hard work?
I don't like them.
Okay, that's why I said it's an optional one. You guys don't want me to finish them? Okay, so dy. Right? Waste time. You're still going to get homework.
How is it optional if it's on the test?
It's another. No, this one's not on the. Is this one on the test?
Yeah.
Oh, then awesome. It wasn't on the presentation, so it shouldn't be.
get a cycle man.
Okay. What goes here? This one I'm going to leave alone, 2, -8, because those are the x values. But because this is the y one, I'm going to put the answers in for y. Okay, so notice that. The answers went in here for y. And over here, they went in for x. And over here, they didn't. So this is going to give me -48.
Oh, bad.
Is this supposed to say USAT, not BELSAT? What's 6 times 8? 48? 56? 48? Okay, I was right the first time. Yay. Okay. Oh, there's going to be something funny with the system. It's a special system, huh? The answers were infinite. Okay, I picked a bad example.
Oh, God.
Yeah, I picked a bad example because the answers, this one was an infinite system. Let me do it with one of the other ones. Okay, you know what? Let me not. Let me show you the easy way then. Is that cool with you guys? If you have a calculator with you, that's awesome. If you don't, then you don't. I'm gonna grab mine real quick here. So Steve, I'm gonna let you out of your pain. Okay? I'm gonna show you some cool stuff here. So I'm gonna use my calculator. Home screen. Everyone cool with that? Right below math is x to the -1. And the second command for that is matrix. Okay? So I'm going to go second, matrix. And I'm going to go over to edit because I want to put a matrix in here. Okay? And I'm going to solve this one right here real quick. Is that cool with you guys? So let me see if I can, I'm going to write it at the bottom so I can see it. It's 2x plus 3y is equal to 19. 3x minus 7y is equal to negative 6. Okay? So what size is this system, this matrix going to be? Well, it's got 2 rows and 3 columns, right? So I'm going to change this so that it reads 2 by 3. And then it puts all the spaces. Easy so far? Let's plug all the coefficients in there. So 2 goes here. So 2, 3, 19, 3, negative 7, negative 6. Well, what did I do? It didn't like my negative? Oh, I didn't like my, okay, so negative 7 and negative 6. Steve, we good so far still? Okay, everyone still good? All right, here comes the magic. Second quit. There's this method in math that you were suffering with, which was row swapping. And eventually what you wanted to do is to get reduced echelon form, or row echelon form is what it's called.
Echelon?
It's called row echelon form. That's,
What is it? Like,
well, slow down. We're not going to teach you that because that's going to. Here's what row echelon form is. What you're going to do is you're going to get in your matrix, you would get a row of 1s like this, and then everything under that would be 0s. Right? You remember that? No, stop. Calm down. We're not going to do that. Okay? And then there'd be numbers up here that'd be okay. We don't want to go there. We're going to go a step further, which is reduced row echelon form. Don't mind any of that, Steve. I'm just telling you because he explained what is it. Okay? Are you ready? Go back to that matrix command. And this time we're going to do some math. And if you push up, there's the 2. Reduced echelon or row echelon form and reduced row echelon form. We want the reduced row echelon form, which is B. So I'm going to go up to B. And which matrix do I want to reduce row echelon? Matrix A. So I'm going to go back into matrix. And I'm going to throw matrix A in there from here. And then I'm going to push enter. You see this here? Those are the answers. We're done. It's not cheating. This is saying that 1x is 5 and 1y is 3. And we're done. That's it. What happened? Is that cool? Well, isn't the first column the x column? And the second column is the y column, right? So what that's saying is 1x is equal to 5 and 1y is equal to 3. So your answers are x, y. Hopefully if you do a 3 by 3, then it'd be z. But you could do that, right? Cool. Which is nice because if you need to do a 3 by 3, then you throw that into matrix, do the same operation, it's going to spit out all the answers. Nice? Cool. All right. I want to do one more. Let's go back to, since we have time. Remember the first one we had to do by graphing? Which was kind of like, bleh, that wasn't it. Here it is. The only thing that you're going to have to do here, 2x plus y is negative 5. Negative x plus 3y is 6. And you guys are going to have to learn these skills if you don't want to sit there and do all this math. Is that we can actually plug them in here. Let me erase the blue because I don't want that anymore. Okay? I can go to y equals, put my 2 equations in there and have it find the intersection for me. So, the only downfall is they have to be in which form? In y equals form, right? So looking at this one over here, the top one, that becomes y equals negative 2x minus 5. This bottom one, once I kick out over that x, that becomes a plus x, right? Is that cool? And then divide everything by 3. So y equals 1/3 x plus 2. We're good? Let me plug them in. So y equals, I don't think it's going to like my negative, so I'm going to use this one. Negative 2x minus 5. Excuse me. There's the first equation. The other one is a fraction. So I'm going to use my division, my parentheses there. 1 divided by 3 x plus 2. So there's my two equations. I'm going to graph it. Oh no, I have a stat plot on. Let me turn on my stat plot. Yeah, good. So 4, enter, done. Okay, so now I'm going to graph. It's still in stat form. Give me a second, okay? You guys see that little wormy there? It just means it's thinking still. You can't do anything until it stops. Okay, cool. So I'm going to go zoom, standard form, which is 6. And I should see my 2 lines. So there's 1 line. And here's the other line. Okay. Now you could see how you could find the answer, right? There's my negative 3, 1. But if I'm not sure, because sometimes it could be decimals, right? Here's what you do. You might want to take a note of this. Right above traces, calculate. I'm going to go second, calculate. And guess which one of those I want to calculate? The intersection of them. So I'm going to say, okay, which is your first curve? Notice the blinker on the blue one. That's the first one. And the other one? Oh, it's the red one. And I can say, where do you think it's at? I'm going to move towards that solution there. Press enter. It's going to spit out my intersection. So there's your graphing method using a calculator. All the others I would use a matrix. Yeah, so there's your graphing method. You can do it that way. Or if you don't want to mess with the graphing, you can throw it in a matrix, which I just showed you how to do.
Can you do it again like that?
Do what again?
The matrix?
Do it in the matrix? Okay, let's take the next example. So here's one right there, which is kind of weird. It's not in. The thing about the matrix, though, you got to make sure that they're both in standard form. So it's got to be the x plus y equals something. X plus y equals something. If it's not, you have to make it that way. But understand, sometimes it's just easier to do it by hand, isn't it? So is the calculator always to your benefit? No. Let's see here. This one's in standard form, so we'll do this one, okay? With the matrix. Oh, we have time. Oh, bell's gonna ring now. We'll do some more tomorrow. Try it out. If you have your graphing calculator, try that as well. You need to get your hands on one.
Oh, it's movie day tomorrow.
Did you guys do the question last night? No, it's not. They were due last night. No, they were due last night at 11:59.
She told me it was due today.